Hello and welcome to Coderific. In this video, you are going to learn how we can access an array in a wave order in Python. In top left corner of the slide, you can see an input image, which is a two-dimensional image, and the output array should be in the order as shown in the arrows. The output should be containing the list of elements starting from 1, 2, 3, then 6, 5, 4, 7, 8, 9, as shown in the order of arrows, and it is called a wave order. So before I continue, I want to remind you that every problem has more than one programming solutions, and this video is about one of those. Before we start programming, I want to give you a quick walkthrough over my algorithm, and the main chunk of algorithm is written in few lines here, as you can see in this block, and the input array that we will be reading in this manner, which is wave order, shown in the arrows, and this is our input array, which is two-dimensional array, and its dimension is 3 by 3. So if you remember, in Python, indices start always from 0, so we will be reading number of rows and columns starting from 0 to 2, and the new array is the same two-dimensional array, and we will be filling out this new array as we iterate through each row and it's all of the columns. So in the first iteration, our number of rows and columns starting from zeros, and in number of rows are being handled by variable I, and columns are handled by j. So whenever we enter each row, we have to iterate through all of its columns. So initially our I is 0, j 0, and inside the column iteration, we need to check that if in variable is remainder to equal to 0, so we need to add new array element, new value. We will be deciding by this variable, and if the condition is false, we have to jump out of if block and enter into else block, and here we are going to update c variable. Actually, here we are going to create negative indices that will index from -1, -2, -3. So very last one index is always referred as -1, and the later indices are moving far from the last indices towards left. And after updating the value c, we will be inserting the value inside the new array. And after we are outside our columns iteration, we are going to update our end variable. So let's start our iteration, where were our initial values of I and j are zeros. Initially, our I and d variable as outside of loop we have mentioned is as 0 is 0, and we are going to check if 0 remainder 2 is equal to 0. Yes, it is. And we are going to run this line where we are going to add new element in new array. So right now we are pointing out to this value, and we are going to enter 1 at position where ij, new array at the position of 0 and 0. Moving on to next iteration of column. Here our new value of j is 1, and we are still under first row, and here we have updated our index value, which is now 1. We are going to check 1 remainder 2 is equal to 1. It is false. It should be 0. So we are inside the else block, where we are updating c value based on 1 plus j. So j value is 1, 1 plus 1 is 2. So we have created negative index -2. So here we are going to say that take value of negative index 2. We are going to start negative indexing. So this is actually -1, and we are going to iterate it back from it. This is -2. So here we are actually on the right place. So we did not access this element directly from I and j value. Rather than we have accessed this element based on negative indexes that we created inside c value. So now we are going to enter 2 where inside new array of I 0 and 1. We have entered it. Moving on to next iteration of column j, where j's new value is index 2. Currently updated value of index is equal to 0 or not. Yes, it is. And we are going to add a new element inside new array I of j, which is I is 0 and 2 here, and current value. We are simply going to access the current value 3. So we have added a new array. Moving on to next iteration where our I has updated to 1 and j has started new iteration starting from column 0, and our index new value is 3, and we want to check if 3 divided 2 is equal to 0. No, it is not. We are under else block where c's new value is -1. So here under this row we are going to access this negative indices. This is -1 of row 1. So we are going to pick this value and we are going to add it where I of j. So 1 of 0. So we are going to add here. Moving on to next value of j. Index value is 4. 4 remainder 2 is equal to 0. Yes, it is. We are going to add new value. And simply we are going to add I of j, 1 of 1. Here what we are going to insert is take input value I of j, which is this one, and we have added here in new array. Moving on to next iteration of last column under second row, and after updating the value of index variable, it's 5, and 5 remainder 2 is not equal to 0. So we have jumped out of a block and now we are under as block where we have updated our c value and its new value is -3. So inside the same row, which is second row, if we start indexing negative up to -3, starting from -1, -2, and -3. So we are going to pick this value. We are going to insert it in new array according to the current position of I and j. So I and j and are 1 and 2. So we are going to add -3 index value here. Moving on to next iteration. Now we have reached our last row and j column iteration has started from 0. Updated value of index is 6. 6 remainder 2 is 0. Yes, it is. We are going to add new element in the new array. So we are going to pick the input array of element according to current position of I and j, which is 7. We are going to pick and add it into the same position of I and j in new array. So we have added 7 here. So that's how my program works. And now let's start programming. So I am back to my Spyder, which is Anaconda's Python editor. I have already imported my important libraries that I'm going to use, one of which is NumPy, most of which I am going to use in my program, and SIO I am going to use to write my output index selected based on wave manner. And if you want to learn how we can write our output indices in mat file format, you can continue watching, and if you don't, you can skip that part. So first we are going to create our input index or input array, that is a two-dimensional array, and its size, as you can see here, 3 rows and 4 columns, so it is 3 by 4. And to create a new output array, we are going to use the same size as of input array. Here we have created a new blank array and it has the same size as of the input array. So I am going to run my program written so far. As you can see here, I have created my input array and the new array is blank filled with zeros and it has the same dimension as input array. Now we are going to create rows and columns so that we can iterate through them. Number of rows will be shape 0. Copy this similar and change the dimension of shape. So if I print here in my console only the shape of matrix, you will see that it has 3 by 4 shape. So these are my rows and these are my columns. So this is shape 0 and this is shape 1. So I have saved my correct dimensions of my input array. Before I start indexing through rows and columns, I have created a variable and initialized it as 0 that will iterate through element by element in my two-dimensional input array, and based on which I will be updating my output array. Next, I have created my for loops. The outer loop iterates through number of rows, and inside each row the inner loop iterates through number of columns. So first I'm going to create an if block where I will check if index value remainder 2 is equal to 0, and let's create else block initially so that we don't miss any indentation. Inside if block I will update my output array based on the current position of I and j with the value of input array according to the current position of I and j. But if this condition fails, it will take us to the else block where I will update C value to create negative indexing, where I will add J value by 1. And besides that, I will update the output array value with the input value based on current position of I and C. And outside of my column loop, I am going to update index variable by 1. So let's start our lines. So as you can see that my output array has been filled with the new values according to wave order. And if I click on the values of my output array, you can see that output array has been filled with values according to wave manner that I have created based on my algorithm. If you notice that the type of my output array is float, I'm going to convert it into integer using as type of integer. So to create a linear array, I'm going to first create an empty array that will carry my linear array. I have created two loops. First, I have created the loop to iterate through rows, and then the second loop will iterate through all columns inside that row, and I'm going to append the value according to j inside my output variable. Let's run this. As you can see in my variable explorer that my output has list as a linear array, and I want to convert it into my numpy array. Let's run it, and I'm going to print this now. Let's print it, and now we have our output array that has been picked in wave order. So my wave order should be indexing through 1, 2, 3, 10, then 20, 6, 5, 4, 7, 8, 9, and 30. So if I go back to my output, and the output should be in the same manner: 1, 2, 3, 10, 10, and next 20, then backward 6, 5, 4, 7, 8, 9, and the last element is 30. Now I am going to write my output indices in .mat file format. And basically here I have saved my output data as a dictionary, and the variable index will be carrying out my output data. So before I show you how to read it back, I'm going to first clear my console and remove all variables, then reload my important libraries. Then I'm going to run only the line. Here I have used the same library of SIO. To write my .mat file, I use savemat, but to load it back or read the file of mat, I am going to use a loadmat function and the name of file. So as you can see in my variable explorer, the handler of mat file has been created as I named here mat underscore contents, and its format is dictionary. And if I click on the values, you can see that the first three show the metadata about .mat file, and the last one is our concerned variable that contains our actual data. Okay, now if you want to create another variable that will hold only the index data, so we can create it the same way as we do with CSV files. We are going to use the handler mat underscore content, and we are going to refer to our name of column or name of data, and we are going to save it in index variable. Let's run this line, and you can see my variable index contains the actual data that I extracted from mat file. This is it for this video. Thank you for watching. I hope you find it helpful. If you did, do like and share. Also subscribe the channel and hit the bell icon so that you get notified whenever I upload a new video. If you have any suggestions, leave them in comments section. I will do consider it. Thank you.